what are the things that we have seen and what are the patterns that sort of hold true when we typically go through a data journey. So this is part of the Catalyst series. In terms of structure, I would sort of walk you through what is typically involved in a data journey, what are the patterns that sort of hold through, and towards the end, we can sort of have a Q&A session where you can ask questions. Feel free to post your questions on the Q&A, which I think you should be able to see as a participant on the Zoom call as well. Right. So just to set some context, right? Like when we talk about a data journey, I think there are a lot of organizations out there which are at varying stages in terms of having everything else in place. But data is something that is not necessarily either structured properly or has issues at various stages, right? In my mind, generally, when I look at a data journey, I think there is an end-to-end goal which you have in mind. And there are various stages that are involved which sort of take you from what's your original ask to something that you have available for users to consume. So typically you would start off with defining some sort of goal and effectively get some data which helps achieve that goal. You would then refine the data by cleaning it, because most data is not necessarily clean based on what your use case is. And effectively then enrich it and then look at sharing any insights on the basis of what enrichment you've done, right? You also would maybe a bit later try to deploy machine learning models depending upon your use case. But at each stage of this process, you would want to iterate so that you can go from start to finish multiple times, right? The first cut that you roll out might be a very simplistic use case, but then you sort of iterate through it and refine it over the course of time. In my mind, in terms of the aspects that sort of really matter for the data journey, I think there are three things that really matter. One is, which is the product thinking, which is about what is it that I want to build, right? It's something that you need to have clarity on. At the same time, you do not want to focus on too many different aspects at the same time, sort of applying the WIP limit in terms of what all you do at the same time, right? The second bit is more in terms of the data science, which is more like the secret sauce, where based on whatever data that you have, you would choose to build models on top of it, which actually provides the insights that you need, right? And lastly, data engineering, which is primarily about having the rigor and practices, which will ensure that you can not just have models which show that the concept can work, but actually have it available for your users and in a reliable way, right? Typically, you would, like in organizations, have these as different people. In my mind, these are different aspects that a single person could have, and you could do different aspects and hence provide much more value than you would typically have if you're just siloed to one specific role. So I think it's also important to balance across all these three, because like the example that I took, if you spend building too many features at the same time, it's going to take you that much longer across your team to actually build something, right? And in some cases, maybe preferably in the early stages, you might want to spend a fair bit of time on data engineering and data science, sort of have the basic building blocks in place before you can move to something more concrete. So before we get into the patterns, I sort of want to take an example and sort of walk you through what are the things that we have done in that space, which will make it a little more relatable, right? So Talon is one of our customers where we've helped them go from pretty much Excel sheets to having a platform where you could have all the inventory and then having the next level where you could have insights coming from data, right? For those who don't know, so Talon is in the out-of-home industry. It's a marketing specialist where typically your clients would want to run a campaign, an ad campaign on billboards, right? These days, you also have the mechanism to do the same on digital platforms like Google and Facebook. But this is largely in the out-of-home space where you have billboards at various points and you want to optimize what you use in terms of campaign, right? So this journey has gone on for a couple of years, and we started from the days where it was based on Excel sheets. And to help bring the basic foundation in place, the first product that was actually built was Plato, where effectively your media owners, who are the owners of the individual billboards, you need a mechanism to have all of this infrastructure at one place so that you can easily book campaigns, knowing that the inventory is actually available, right? And then you can actually track your campaign as to how effectively is it going through. So this was the first phase where we built the basic blocks to have the inventory booking in some sense, right? The next level of it was ADA, which is where we've spent a fair bit of time with data by processing billions of device data points. You can look at it as like an anonymized trail of a individual device, which sort of tells you how people have been moving around, right? Now, if you overlay this information with different data sources, you can sort of help bring a very rich experience in terms of advertising, right? So you have your inventory, which is where all my frames actually are, and you have a trail of where people might have been. Then you can actually try to make inferences in terms of which frames might have been seen by people. They're not necessarily going to be extremely accurate, but we do account for a fair bit of data and factors to make those inferences, right? So this effectively lets you do an audience segmentation and target and then build a campaign which is much more driven by data than just by insights based on experience in the industry, right? So now maybe let's get into the patterns, right? So the first one I think that has worked really well is in terms of having thin slices of the model, right? So typically when you're building something new, it's easy to fall into the trap of trying to refine it substantially, improving the accuracy and everything else before you have the first one available for consumption. This basically increases your cycle time in terms of what an end user can actually try out before it's fully ready, right? So you want to sort of minimize this time so that you can have a basic working model, right? So you start small, define a baseline, push it all the way till production, and then with every subsequent feedback loop, you try to improve it, right? In the case of ADA, for example, we had to build a model which identified which audiences visited which mods, right? The most basic model that you could do in this case is to just look at how many distinct devices were found inside a mall boundary. That gives you a good pass in terms of what is the relative rank of each mall in terms of number of visits. It doesn't necessarily work for all cases, but it gives you a high level comparison, right? And then your users can look at it and effectively say that this does not necessarily look right for certain malls. And then you can go and further refine it by accounting for other things like dwell, which sort of makes it easier because in some cases you might have a person just visiting a mall, but then stepping out immediately. That doesn't necessarily qualify as a visit. In a mall, you would typically spend a fair bit of time, right? So that's where you could take another slice of the entire model, take it all the way to the production by accounting for things like dwell, right? The next, you could keep going further with every subsequent pass and make it a little bit better than what it used to be, where maybe you can have things like the periodic refreshes of the mall boundaries, right? Over time, you might have the mall boundaries changing, or you might have new malls coming up. So these are things where having thin slices lets your business users consume the data much more sooner. Of course, the accuracy might be a bit lower, but at least you have a working model, right? And this also lets you choose to shift your focus to something else, where maybe after a couple of iterations on a particular model, you think this is good enough, and you can choose to focus on something which is much more important and valuable to the business. The next one is again related and more in terms of allowing the business users with early access, right? Typically, you would have some sort of user interface with which the users can interact with the system. This will consume the capacity of your engineering team, where they would need to build the relevant components so that you can actually use it as a user, right? But it's not necessary to wait all the way until the last minute, right? What you could do is provide access to the lower level systems where maybe the users can directly query via SQL interfaces, or even use dashboarding tools like Superset or Looker, which then lets the business users actually slice the data and see whether this actually makes sense. That way, you will get feedback much more faster, and you will be able to make fixes much more sooner as well, right? Which again reduces the cycle time. There are a lot of things that you would typically not notice as someone who might be building the model. Things like differences due to seasonality or ad hoc events. All of those are something that people who have been there in the industry can spot very quickly, and will be able to collaborate and sort of identify what are the next steps to improve that, right? The next one is actually a fairly common problem, which is in terms of having a gap in terms of how the data scientist and a data engineer would operate, right? Typically, for a data scientist, you would look at building some sort of model based on a sample data, have it maybe working on your machine, and then that you would refine with various types of models, right? But the reality in production is that you might not necessarily have libraries available at that scale, which sort of increases the entire end-to-end cycle time, right? And as you have more silos, it sort of makes that problem go multifold. So it's important to cross-pollinate, where maybe you sort of also learn a little bit of data science, or have people understand the overall ecosystem and try to use systems which make it easier even for data scientists to operate on a larger data. And that way you can look at reducing the entire time to sort of go from model exploration to productionizing it, right? In the case of Ada, we also did few changes. Initially, we started off with a bunch of different data science models because we had to build a fair bit of them. But we also aligned ourselves to sort of match the data engineering throughput, so that you don't have a bunch of data science models that are ready only at the model stage, but you also take them all the way to production. So that way you're looking at reducing the amount of things that are in flight, but at the same time delivering value much more faster. The next one is more in terms of model experimentation, right? Like once you have a working model in place, refining it is a slightly more trickier job, because now business users are actually consuming it and they rely on the insights in terms of value that they provide, right? So you don't want to break this in any way. So in that sense, it sort of becomes important to have a framework with which you can have like a new model rolled out very safely. At the same time, if something goes wrong, you want the capability to go back to the older version until someone sort of looks at it and fixes the underlying problem. There are a lot more advanced techniques that you could use here. You could also look at building an A/B testing capability, where you could have multiple models or versions of the same model live at the same time, and you could A/B test them to see which one functions better. In the case of Ada, we didn't necessarily need the A/B testing mechanism. We used feature toggles, which was simple and lightweight. And effectively, if there were issues, we would sort of roll that back, and business would continue as usual. But that sort of reduces the amount of risk that we would typically face when we are going to roll out a new version of the model. This is more in terms of how you approach data science, right? Like now with machine learning and AI, there's a lot of easy off-the-shelf models that you can easily use. But I think the key point to understand there is, how do you sort of refine those models as the business asks changes, right? So typically you could also start off with simple models, which just help and assist the users. You also want to have some sort of metadata attached with your data, so that you can reason about whatever insights that were generated. So this might be things like confidence scores or any other attributes that sort of help make the data a little more explainable, right? There are a lot more things you can go in terms of making it predictive and everything else, but in my mind, honestly, you start simple and sort of refine it with every subsequent iteration. In the case of Ada, we didn't necessarily go with machine learning. We went with data science models, which we could understand and interpret. And we had business validation in place. Given it was all anonymized data, you have no way of knowing whether a particular model actually works. But we had some ways of comparing against, let's say, industry data points, right? Or even census data points to say, yes, this sort of makes sense, and we can go ahead with this for now. The next one, again, is more in terms of things in the data engineering space. I think there's a choice in terms of whether you choose to build or you choose to acquire, right? And it's important to make that choice because not everything is going to be central to your business. You should choose to focus on what is central to your business and build that instead of looking at peripheral data systems, right? And choosing to build that, because building a reliable, timely, and a high quality data set is not trivial. You want to need some sort of workflow so that you have the right quality checks in place and some way of measuring the ground truth, right? In the case of Ada, inventory definitely was central to the system, right? But we didn't necessarily care as much about whether those device data points were from apps that we had, right? If you're going to go down that path, there are a lot of things that you need to take care of. There are providers who sort of provide this data, who ensure that there's a certain quality in place. And in addition to that, you can always have your data quality checks in place, which makes sure that whatever data you've signed up for matches the quality expectations that you have in mind. So that way you end up focusing on the right aspects and you don't have an opportunity loss by focusing on the wrong ones. The next one is more in terms of a choice that you would typically make, which is whether should I go for real time or batch in terms of the way that I build a system, right? Honestly, this depends more on what sort of use cases you're planning to tackle. Batch sort of makes a few things a bit easier in terms of how do you reconcile, what are the data quality checks that you can add, and things, and the tooling is also a lot more mature, right? In the case of real time, you get insights fairly quickly. And of course, you can build systems in a way that you can replay and rebuild the stores, and of course, plug into even existing ecosystems. But I think the choice is something that depends truly on the basis of the use case, right? If you're going to look at maybe things like in the case of a shopping cart, if you want to recommend products, you might want to do that almost on a real-time basis, right? In our case, it was data that we would typically get weekly, daily, or quarterly, and that's something that we can take care, right? So the next one is more in terms of, again, leveraging existing solutions. There are a lot of cloud native solutions that are out there, right? So things like if you're managing a big data system, things like S3 or any data object storage, which sort of does a good job in terms of durability and availability, you can just leverage that instead of choosing to build that, because that's definitely not going to be central to your business, right? And also you need to structure it in a way such that these systems are peripheral and can be swapped if the need happens that you need to shift from one cloud to another. In the case of Ada, for example, we chose to make we chose to go ahead with something like S3 and Athena because it provided a lot more value for the lock-in in some sense that was attached to it. The same for RDS, because you get a managed database for very little risk, right? And in the case of any platform services that we build, we chose to Dockerize them because that sort of makes it easier to go away if you want to go out of it, right? Okay. The next one is more in terms of prioritizing by return of effort. Sorry, should I let me know if I should answer some of those questions right away. Otherwise, I can take a moment and answer those. Otherwise, I'm sort of going to continue for now. So the next one is more in terms of prioritizing by return of effort. So effectively, if you look at Ada, for example, we process TBs of data every week. And as that data sort of accumulates, you're going to have a cost problem associated with it, right? Because storage, while it is cheap, as you accumulate data, that's going to get expensive as well. Now, you want to sort of prioritize this at the right time, because early on, you're not going to have as much data, right? You could instead focus on building various business use cases. And once you have enough data available, you can then choose to have the systems in place where you might look at archiving data or even deleting data based on how things pan out, right? We also chose to use spot instances, which are which is a capability that AWS gives you, where the pricing is much more reduced as compared to the on-demand price that you would typically pay. That sort of makes your infrastructure in general much more cheaper to operate, and we would only spawn it when we want to process the jobs, right? In our case, since the data used to come either daily or weekly, we would run the jobs and then effectively shut down the clusters, and that way you would save down a lot more on the cost than otherwise, right? So there are certain parts that we sort of chose to take early in terms of, yes, for this job is going to run every week, and the cost for it is going to be fairly high if we run it at full cost. So we chose to use cost saving mechanisms out there, versus in the case of storage, the cost is much more lower initially. So you would sort of delay that and do the cost optimization a bit later. The next one is more in terms of regulatory compliance. This is something that's happening more and more across various countries now, and sort of important to have this in place right at the start, right? So this clearly can't be an afterthought. But at the same time, if we, let's say, take the example of a fintech startup, right? You would think that storing like credit card information or whatever is central to their business. But if you are building maybe something slightly peripheral to it, then you need not store that information either. There are a lot of startups out there which will deal with the personal information themselves. They will ensure that they have the right security, everything in place. And what you get instead is an anonymized handle to that PI information, which is basically interpreted on the fly when you make a request. So effectively, within your ecosystem, you do not have any PI information. What you have is a reference to API information, and all that data lives in a well-tested sandboxed place, which is a separate environment, right? So in that sense, it lets you focus on your business use case and not worry about PII by delegating that responsibility to someone else. So it's important to think about, is it something that is central? Just having the data is not going to help you in any way. You're going to deal with a lot of regulatory asks if you store PII. So you might as well just stay away from it, focus on your actual business ask, and should the need arrive someday where you need PII, then you can build systems or leverage off-the-shelf components which take care of it for you. In the case of Ada, we don't necessarily have any PII, right? So effectively, you would look at having audit logs, encryption of data, and trying to secure and archival policies so that you can have all of those things in place. The next one is more in terms of eliminating data downtime. This is a very real issue with any data processing platform, right? As you accumulate data and as you create insights, the insights are going to be only as effective as the quality of the data. If the data isn't good, it's basically going to be garbage in, garbage out, right? So you need to look at having have data quality checks in place, which ensure that you have some measure of accuracy or timeliness out there, right? You can start off with addressing the ones which are externally sourced. So if you have chosen to import data from elsewhere, those are the things that you want to have checks in place, because that way you're preventing bad data from entering a system, right? Within the models that you have built, that's another place where you could choose to have data quality checks, and that will ensure that whatever insights you generate are also equally good as well, right? Typically, in a data pipeline, you would have like upstream and downstream jobs. So you need to worry about data cascades, right? So if an upstream job fails or rather has bad data, it's going to affect every downstream job that consumes it, right? And if some of those jobs are critical for business, the impact is much more higher. So you want to sort of address those ones early on and have the necessary data quality checks in place, so that if there is any issue, you can sort of stop the pipeline investigate the issue and choose to take action, right? In the case of Ada, we chose to use frameworks like DQ and have Slack alerts, so that if there is any bad data that is flowing through, you can actually get an alert, and then someone from the team can go and look as to what is wrong, right? And typically in large systems, you also want to go more with anomaly-based checks rather than having absolute checks, because otherwise you're going to look at alert fatigue, right? Just having alert after alert coming in doesn't really make sense. You want to know about alerts only when it affects your system, right? So maybe a 0.05% bad data does not affect you as much, but if it is substantially off, maybe that is something that you need to take care of. So, I mean, as a summary across all of the things that we did in Ada, right? We didn't do all of this in day one. We chose to address various aspects of the problem as and when they showed up, and then chose to make the relevant, like applying the relevant pattern based on what problems we saw. This was the journey that we saw in Talent, and it could be very different for what you might be seeing in your organization.